Good morning, everybody. We're starting a new unit today, Unit 6, which is all dealing with linear inequalities. So we've solved linear equations before when it was like 2x equals 3. But now, instead of an equal sign, we've got these inequality symbols. So let's go through these and make sure we understand what each of them represent. So this first one is less than. And the way I sometimes think of that is it looks like an L. If I were to kind of stretch it out, it looks like an L, so that's less than. And then the second one is greater than. The next one looks like a less than symbol, but it has this line underneath. That means less than or equal to. And then the last one looks like greater than, but it's got the line underneath, so that's greater than or equal to. So, like I said, we've dealt with equations before when we get like an x equals a number. So like, for example, x equals 2. But now what we're going to be looking at are inequalities where we might see something like x is less than 2. And that means that anything that is less than 2 satisfies the inequality. So you don't just have one solution like x equals 2. You have x is less than 2. So like -1 works, -22 works, 1 works, 0 works, -1,000 works, because all those numbers are less than 2. Okay? If you have something like less than or equal to, so like if you have x is less than or equal to 3, that means 3 also works because 3 equals 3. And anything less than 3 also works. Okay, so we'll get into that a little bit more when we start to solve, but make sure you understand those phrases and what your inequality symbol is. Okay? And we're also going to be graphing linear inequalities on a number line. All right, and if you have less than or greater than, the place where you start, like if you have x is less than 5, you would start at 5, and the circle that you would put there is open because you do not include that 5. The less than or equal to or greater than or equal to, your circle is going to be closed, signifying that that number does work. And then if it's less than or equal to, you shade to the left on the number line. And if it's greater than or equal to, you shade to the right. So we'll get into those circles and the directions to shading, what that looks like after we solve some. Okay? But when we're graphing inequalities, we need to think, do I have an open or a closed circle, and do I shade to the left or to the right? So here we see two examples of an inequality. Example 1a, we've got x is less than 6. So I'm starting at 6, and I'm going to put an open circle at 6. And since it says x is less than 6, I'm going to shade off to the left. That's signifying the region where a solution is. Like right here, 2 is a solution because 2 is less than 6. Down here, -7 is a solution because -7 is less than 6. So any number all the way up to 6, but not including 6 because it's an open circle, is a solution to this inequality. It satisfies it. Okay? And then in B, we get k is greater than or equal to -5. So I find -5 and I start there. I'm going to do a closed circle because I can include -5. -5 satisfies this, right? -5 is greater than or equal to -5. And since it's greater than, that means any number above -5 will also satisfy this inequality. Like if I plug in 0, 0 is greater than or equal to -5. That works. If I plug in 5, 5 is greater than or equal to -5. So that works as well. Okay, so that's what I mean when we say we're graphing the inequalities. We are shading the region of all the numbers that satisfy the inequality. Okay, now let's get into solving inequalities. So we've solved equations before, right? We've gotten the variable by itself. And we've done that by undoing the operations. So like if we have x plus 5 equals 10, we would subtract 5 from both sides. Your adding and subtracting, like to undo adding and subtracting and multiplying, dividing, when you're dealing with inequalities, it's the same exact process. But there's one added thing we got to be careful of. So like, let's say we have the inequality 4 and 2. What symbol will we put there? 4 is greater than 2. Okay, so then we get 4, let's say we multiplied both numbers by the same thing. We get 4 times 3 is 12, 2 times 3 is 6. So the inequality symbol stays greater than. Same thing if I'm dividing by a positive number. So we got negative 10 is less than negative 5. If I divide both of those by 5, I get negative 2 is less than negative 1. The symbol stays the same when I multiply or divide by a positive number. But what's it going to look like when I multiply or divide by a negative number? Here's where the twist comes. So we know 7 is less than 9. And if I multiply both sides by negative 2, I get negative 14 and negative 18. The symbol there needs to flip, because negative 14 is greater than negative 18. All right, so when I multiplied by a negative, I had to flip that inequality symbol. What about 15 is less than 18, but 15 divided by negative 3 is negative 5, and 18 divided by negative 3 is negative 6. So once again, negative 5 is greater than negative 6. When I divided by a negative, I had to flip the sign. So this is the super key thing that makes this different than solving equations. Because when I multiply or divide by a negative, the inequality flips. And this right here is super key. You must remember this. This is what makes inequalities different than just solving regular equations, is when I multiply or divide by a negative, the inequality flips. Okay, so let's do some problems and see this. Make sure you're always reading left or right, and if you multiply or divide by a negative, you got to flip-flop the inequality symbol. All right, so we got negative 18 in example 2. We got negative 18 is greater than negative 7 plus 4b plus 1. So we're going to solve this just like we have been with solving equations. I'm going to combine like terms on this right-hand side. So I get negative 18 is greater than negative 7 plus 1, which is negative 6, plus 4b. All right, so we got negative 18 is greater than negative 6 plus 4b. My next step, I'm going to add 6 to both sides, because I'm trying to get that b by itself. So I got to get this 4b by itself. So I'm going to add 6 to both sides. Negative 18 plus 6 is negative 12. So negative 12 is greater than 4b. And then last step, I'm just going to divide both sides by 4. And since I'm dividing by 4, a positive 4, I do not need to flip my sign. Negative 12 divided by 4 is negative 3. So I get negative 3 is greater than b. Okay? Normally, we want the variable first. So if negative 3 is greater than b, if I flip this around, it would be the same thing as saying b is less than negative 3. Okay? Both of these answers are saying the same thing, so they're both technically correct. It is just more traditional and common to have your variable be first. That way you can see what the relationship is with that variable. B is less than negative 3. So if I were to graph this, b is less than negative 3, I have an open circle at negative 3. And if it's less than, I'm going to shade off to the left, because it's saying anything less than negative 3 will work for this inequality.